If you've ever been in a greenhouse like this one, you know that it can get quite warm in here, even in the winter. You also know that it stays quite warm even overnight when the sun goes down. That's because the sun's energy comes in as light and then it gets trapped in here. The heat gets trapped, it can't escape. This is great for these plants, it stays nice and warm in here. Did you know that the Earth is kept warm in a similar way? We don't have glass walls all around our planet, but we have something that traps the sun's energy and keeps the heat inside. Unfortunately, there's a problem though. The Earth is getting warmer and warmer, and it's threatening the balance of our biosphere, the living portion of our planet. Let's take a look at this threat and why it's happening. When solar radiation hits the surface of the Earth, a lot of it is absorbed by the surface and it warms up the surface. Some of it though is reflected, and some of it goes and escapes to space, is lost as heat to space. But there's also some gas molecules in the atmosphere that can actually reflect the energy back to the surface of the planet, and that makes the surface even warmer because more of it's being reflected back down and able to be absorbed and warm up the planet even more. This layer of gases in the atmosphere acts like the walls of a greenhouse. It traps the energy, traps the solar energy inside and warms it up. This is known as the greenhouse effect, named for the fact that the greenhouse gets warmed by the trapping of the heat inside. So these gases are acting in the same way. They're trapping the sun's energy, the solar energy in, and keeping the heat in and warming up the Earth. Just like a greenhouse effect. Without these gases, without the greenhouse effect, the Earth would be too cold for life as we know it. The issue is that over the last 100 years, the Earth's global temperature has increased by 1.3 degrees Fahrenheit. It doesn't seem like that much, but let's just take a moment to think about the fact that it only takes a difference of 13 degrees Fahrenheit, really, between an ice-covered Earth and an Earth without ice at all. So the global temperature of the Earth is a matter of 13 degrees between the difference of being totally ice-covered and not having any ice at all. Most scientists agree that this acceleration of warming of the Earth, this acceleration of global climate change, is caused by an increase in carbon dioxide in the atmosphere. Carbon dioxide is a greenhouse gas. And greenhouse gases are gases in the atmosphere that trap the heat that's radiating off the surface of the Earth and prevent it from escaping to space. More of these greenhouse gases means an increase in the greenhouse effect, thereby keeping more of the heat inside and warming up the Earth even more. So let's imagine that the Earth is inside a greenhouse. And let's imagine that this greenhouse has some holes in it because the gases in the atmosphere are not solid, so some of the heat can escape into space. But as we put more and more carbon dioxide and other greenhouse gases into the atmosphere, think of it as like we're plugging up those holes. We're covering up the holes with more glass, thereby keeping more heat inside. The more heat inside, obviously, the warmer it gets. So as we put more gases into the atmosphere, we're basically stopping heat from escaping into space and thereby keeping the Earth even warmer and causing it to warm up faster than it was naturally. There's more carbon dioxide and greenhouse gases in the atmosphere because of the burning of fossil fuels. Fossil fuels are called fossil fuels because, like fossils, they come from plants and animals that died millions of years ago, and over time, with pressure and heat, have turned into fuels like coal, natural gas, and oil. This organic matter that was trapped in the Earth through these fossils when the organisms died gets released out of the Earth into the atmosphere when we burn them for fuel. Destroying forests is another cause or another way that we're accelerating global climate change. By burning forests or destroying forests, we are taking away the trees that take carbon dioxide out of the atmosphere. Plants take carbon dioxide out of the atmosphere during photosynthesis. They use that carbon dioxide in photosynthesis to make organic compounds, to make carbohydrates or sugars. So by taking these plants away, we are reducing the filtering of carbon dioxide out of the atmosphere. So between burning fossil fuels and putting carbon dioxide into the atmosphere and cutting down or destroying forests, stopping the removal of carbon dioxide from the atmosphere, we are adding more carbon dioxide, more greenhouse gases to the atmosphere, which increases the amount of heat that's kept inside and increases the global temperature. So between the burning of fossil fuels and the removal and limiting the removal of carbon dioxide by harming the oceans and by cutting down forests or destroying forests, we are increasing the amount of carbon dioxide, and that's like adding more glass, filling up the holes, keeping more heat inside, thereby raising the global temperature. How has global warming affected Earth and the life on it? Here are some examples. Species that are adapted for cold climates are declining in population. Glaciers are melting and causing sea levels to rise. More flooding along the coast and shoreline erosion. Heat-related health issues for humans. More droughts and water issues. As oceans warm, water evaporates, causing more frequent and stronger storms, like hurricanes. This also changes the precipitation patterns. Major crop losses are occurring. Here's another effect. The oceans are like a giant sponge absorbing carbon dioxide. Due to diffusion, with the higher amounts of carbon dioxide in the atmosphere from our activity, higher amounts in the atmosphere, lower amounts in the ocean. Carbon dioxide is going into the ocean. Carbon dioxide in water makes carbonic acid. The changing pH is damaging coral reef and ocean ecosystems. Those are all global impacts, but what about impacts in our own state here in the state of Pennsylvania? Here in Pennsylvania, the temperature has already increased 1.8 degrees Fahrenheit in the last century, and it's expected to go up another 5 degrees by the year 2050. Precipitation has already increased 10%, and in some places even 20%, and is expected to go up another 8% by 2050. Warmer temperatures lead to more ground level ozone, and warmer, wetter weather leads to mold, which is causing problems for people who have asthma and other health related issues. PA farmers are seeing a higher rate of direct crop damage due to intense precipitation events. In 2018 alone, severe weather led to $125 million worth of damage in the state of Pennsylvania due to flooding and landslides. Pennsylvania already has the highest number of Lyme disease cases in the United States, and with this warmer weather, those numbers are expected to increase even more. Invasive species are going to be a bigger issue. They're more resilient than our native species, and they're going to be able to do even more damage than they do now. New invasive species are going to be able to move in and cause even greater damage to our ecosystems. Warmer temperatures mean an increase in mosquito-borne diseases such as West Nile virus and Zika virus. Efforts to reduce future global climate change involve mainly energy use. We need to use less energy by driving more fuel-efficient cars. We also need to switch to energy sources that are renewable, like solar and wind power. At the same time, we can increase the amount of carbon dioxide that's removed from the atmosphere. We can stop cutting down or burning forests. We can plant new trees to increase the forest. We can drive legislation by voting, choosing candidates that are aware of global climate change and are making efforts to reduce the climate change. Show them that we care, so they should care. Step one is always to be aware of the issue. Step two is to look at the data so that we understand the issue more and then can start looking for solutions. We need to make sure that we make our decisions based on data instead of what's convenient or easy. This is a global issue, so we all need to cooperate to find the solution. Number one, Global climate change is real. It's happening naturally. It happens naturally. It's been happening for billions of years, long before humans were here, and it will continue as long as the Earth exists. Example, the ice ages. There were ice ages here on Earth. We don't have an ice age now. Why? Global climate change. Number 2, we have to know the difference between weather and climate. Weather is the here and now. Right now it's a sunny day in the mid to upper 60s. This is the weather today. This is not the same as climate. Climate is the average weather over a period of time, usually many years. So we could say like the climate of this area is we have hot, humid summers and cold, snowy winters, moderate fall, moderate spring, right? It's not going to be that way every time. We don't always have hot, humid summers, or not every day is hot and humid, just like we don't always have freezing, frigid temperatures and snowy winters. So we can't use today's weather as evidence for global climate change or against global climate change. And number 3, along those lines, global climate change is global, meaning that we can't just use this particular location as evidence for or against solely. We can use it as part of the evidence, but not solely for the evidence. So some areas will see an increase in temperature more than other areas. Some areas will see more precipitation than other areas. There will be greater effects in certain parts of the world. So one location by itself is not enough evidence for or against global climate change. We have to look at exactly what the term is: global climate change. As always, if we know better, we can do better.